In this video, we're going to take a look at matrix multiplication. So let's think back to the dot product of two vectors, which we discussed in an earlier video. So let's say we take a couple vectors with three components. Say there's our first vector. We're going to do the dot product of that vector with the vector 1, 5, 6. So remember that the dot product operation tells us to multiply the first pair of components, so 1 times 1, and we're going to add on the product of the second components and add on the product of the third components. So just pairing up the matching components, multiplying them together, and then taking the sum. So what we're going to end up with is a number. This dot product, if we add this all up, we've got 1 minus 15 plus 12, so that comes out to the number -2. Now, in order to talk about matrix multiplication, we're really going to be building it up in terms of the dot product. So it's handy to have a little recap of that dot product before we start talking about our matrix multiplication problem. Let's say we have a matrix A. That looks like this. So it's a 2 by 3 matrix because it's got 2 rows and 3 columns. And we're going to take a matrix B, which looks like this. Okay, B has 3 rows and 2 columns. So just to remember the sizes here, we'd say A is 2 by 3, and we'd say B is 3 by 2. All right, well, if we wanted to try multiplying these two matrices together, what we're going to need to do first is circle the rows of A, and we're going to circle the columns of B. So circle the rows of the first matrix, columns of the second matrix, and what we're going to be doing is building a bunch of dot products. So in the position in row 1 and column 1, we're going to have the first row of A dotted with the first column of B. So to get the 1, 1 position, we're doing row 1 dot column 1. As we move over across that top row, now looking at our next entry here, it's going to be in row 1 and column 2 position. So we're going to do row 1 dot column 2. Okay, and that refers to the first row of A, the second column of B. Now, at that point, for the first row, we're going to stop because B only has 2 columns, so we don't need to go any further than that. Now we'll go down into the second row. So we're now in row 2 in column 1. We'd be doing row 2 of A dotted with column 1 of B. And then finally we'll get row 2 dot column 2 in the 2, 2 position. So row 2 of A dotted with column 2 of B. The main thing to remember here is that the rows refer to A and the columns refer to B. And if we had circled those right at the beginning, then that helps to keep it clear when we're going through this calculation. So let's try working out what AB looks like. So in our row 1, column 1 position here, we're going to be doing row 1 of A dotted with column 1 of B. So that dot product is going to look like 1 times 3 plus -7 times 1 plus 2 times 2. So we're just taking the dot product of this row here with that column there. So at this point, we just need to ignore the fact that one vector is written out horizontally and the other vector is written out vertically, and just really think back to the main dot product operation. We're pairing up the first components, we're multiplying them together, and we're building a little sum of these products. So then we add on the -7 times 1, and then we add on the 2 times 2. Okay, so if we work out what this dot product looks like, it's going to be 3 minus 7 plus 4. So that gives us 0. Okay, and then moving across that top row, what we're doing is we're sticking with that first row of A, but we're now doing a dot product with the second column of B. So row 1 and column 2, if we form our little dot product, we can think about what the products are going to look like. The products will be 4 and 7 and negative 2. So if we add up those numbers there, it's handy to do this on your calculator so you don't have to remember so much in your head. But if you do 4 plus 7 and minus 2, we get 9 for a dot product there. Okay, now continuing into the second row, that means we're going to be using the second row of A and now doing the dot product with the various columns of B. So if we move into this position here, which is in row 2 and column 1, we're going to do row 2 of A dotted with the first column of B. So you can check on your calculator, that dot product is going to come out to 13. And as we move into row 2 and column 2, we're doing row 2 of A dotted with column 2 of B. So if we work that out, that's negative 7. Okay, so maybe for the purpose of this calculation, I'll just show you one other calculation. For example, how did we get 13? Well, we did row 2 of A dotted with the first column of B. So it looked like 0 times 3 plus 1 times 1 plus 6 times 2 was where that number came from. All right, so generally when we're doing the multiplication, we won't show all these intermediate steps here. It's just convenient to do that when we're getting used to matrix multiplication. But generally we'll do this intermediate calculation on our calculator and we'll just write down the answer. So there is our matrix AB. Now let's talk a little bit about the size of this matrix AB. The size of A, remember, was 2 by 3. So we took a 2 by 3 matrix and we multiplied it by B, which was a 3 by 2 matrix. Now what happens is that these two inside numbers here, these must be equal in order for the multiplication to be defined. The vectors here that we've circled, they've got to have the same number of components so that we can make a dot product. If these two numbers were not equal, we wouldn't be able to come up with a dot product and we wouldn't be able to say what that first number is in the matrix. So we wouldn't be able to build any of these numbers that we came up with in the calculation. So that's the first thing that we'll check when we're doing a multiplication, is just that those inside numbers match. If they are, then we can do the multiplication. And when we build our product here, your result will be just the size corresponding to the outside numbers. So you check that the inside numbers are the same. If they are, then you can just cover them up. You can say, okay, we checked that they're equal. Yep, they are. And what we're left with is a 2 by 2 matrix. So we could have figured out in advance, if we had thought about it, that AB would be a 2 by 2 matrix. Okay, so a typical matrix multiplication problem. Let's give ourselves a few matrices here. Got A, B, and C. Okay, and let's find a few different products. So for part A, let's find the product AB. So before we do too much work, let's check that the sizes are compatible. A is a 2 by 2 matrix. B is 2 by 1. Remember, we always talk about number of rows times number of columns. So B is 2 by 1. We check that the inside numbers are the same. Yep, they are. So that means we will be able to do this calculation. And if we cover up these two inside numbers here, what we're left with is a 2 by 1 matrix. So AB will be 2 by 1. Well, let's figure it out. To get our matrix AB, let's write down our two matrices. And to get us going, let's circle the rows of our first matrix and the columns of our second matrix. Well, in this case, B only has one column, but I'll circle it just to show the general procedure there. Okay, so now to get our product, we're going to do a bunch of dot products. So in the row 1, column 1 position, we're going to take row 1 of A dotted with column 1 of B, and that will give us -4. Okay, there's no more columns in B, so that's the end of that row, and we can now move down to row 2. In the row 2, column 1 position, we're going to do row 2 of A dotted with column 1 of B, and that's going to give us 6. Okay, and again, we're all done there. So indeed, we do have a 2-by-1 matrix. So the number of rows is the same number of rows as your first matrix had. The number of columns is the same number of columns as your second matrix had. All right, part B, let's try doing the multiplication in the other order. So B times A. Well, again, before we do too much work, let's check that the sizes are compatible. The size of B is 2-by-1. So we're going to take a 2-by-1 matrix and we're going to multiply it by A, which is 2-by-2. So if we check out our inside numbers, they are not equal. And that tells us right off the bat that BA is undefined. If we did try to build this product, we would find that the dot product just doesn't work. The sizes of the vectors are not compatible. So it's best just to check this little calculation here before you even write out the matrices, because it will save you a bunch of time in many cases. So one thing we can notice then, AB came out to the matrix -4, 6. BA turned out to be undefined. So we're going to have to be very careful about the order of the matrices when we're doing our multiplication. Okay, let's do one more part here. Let's say we wanted to find AC. Well, A is a 2-by-2 matrix. C is a 2-by-3 matrix. The inside numbers match, so the multiplication is defined. And if we ignore those inside numbers there, we actually get the size of AC. So AC will be 2-by-3, just looking at the two outside numbers there. That gives us a way of, to some extent, double checking our work. So our answer should come out to a 2-by-3 matrix if we've done everything correctly. All right, to get AC, let's write out our matrix A, followed by our matrix C. Let's circle the rows of our first matrix and the columns of our second matrix. And we're going to build some dot products here. So to get the first row, you're sticking with the first row of A, and you're going to do the dot product with the various columns of C. So row 1 of A dotted with the first column of C, we're going to get 1. If we now do row 1 of A dotted with the second column of C, we're going to get -1. And dot product with the third column of C, we're going to get -3. To get our bottom row, because we're now in row 2 of this matrix, we need to use row 2 of A, and we're going to do the dot product with the various columns of C. So dot product with the first column is going to be 0. Dot product now with the second column is going to be 2. And finally, if we do the dot product with the third column, 4.